If it never stops raining while you're alive, how would that feel? I enjoy when it rains. It feels like the atmosphere of the world changes somewhat when it rains. It's like a change of mood happens occasionally. In other words, it means that having rain occasionally amidst clear days is nice. If it continues to rain without stopping today, tomorrow, on Thanksgiving, Christmas, and even on the day of your date, it would be really terrible. There was a very long rainy season on Earth. Today, I'm going to talk about this period. 250 million years ago, at the beginning of the Triassic period. The planet was sweltering, with the oceans hotter than your bathtub and the air full of carbon dioxide from constant volcanic eruptions. And the supercontinent Pangea was mostly a vast stretch of flat and dry land. Temperatures were getting increasingly higher. Evidence of just how hot and dry the world was at the start of the Triassic is trapped in the land beneath our feet. Rocks from that period are mostly swaths of red sandstones and soil deposits from dry woodlands, with no sign of the coal swamps that had covered the world during much of the Permian. And one major reason that the world was so dry was the shape of Pangea. With all the continents locked together, rain clouds couldn't move much past the coastlines, and there were no big mountain ranges to break up the low, arid land. Early reptiles and mammal ancestors thrive in this sweltering land, dominating a landscape that's still struggling to recover from the Permian extinction. For about 1 million years, Earth's atmosphere became so humid and warm that rain eventually managed to reach even the central parts of the supercontinent. The rains finally came to this hot, dry world. And then this rain stayed for 2 million years. It's no wonder that such dramatic climate changes led to the transformation of the animal and plant world of the planet. This period of intense rain killed off many of the early reptiles. This time is known as the Carnian Pluvial episode, and it set the stage for a new group of animals to take over the world: the dinosaurs. But how did scientists learn about these events? Usually they collect information about ancient climate changes from rocks and plant fossils. Instead of finding red, slowly deposited sand, they found thick layers of river rocks, sediments from giant lakes, and evidence of coal swamps. All of these were signs of massive rainfall over the course of some 2 million years. But stranger still, these traces of a suddenly wet climate turned out to be everywhere, from England to the Americas to Israel, in regions that were far apart at the time. This could only mean one thing. 234 million years ago, it was raining all over the world. Initially, other geologists were skeptical. Couldn't these rocks just be explained by a lot of big local floods? Well, over the next 2 decades, reports of more and more weird rocks kept trickling in, and they kept pointing to a world that was getting wetter and wetter. The rocks revealed coal deposits in Austria, traces of ancient lakes in Italy, wet soils in Utah, and giant rivers in China. And they all dated to the same window of time between 232 and 234 million years ago. In time, this phenomenon came to be known as the Carnian Pluvial episode. The Carnian is the name of the geologic age within the Triassic when this all happened. And pluvial means rain, and it rained a whole awful lot. For example, one estimate suggests that the average annual rainfall in what's now Utah almost quadrupled, reaching a peak of 1,400 millimeters, or about 55 inches of rain a year. For context, that's how much that a temperate rainforest gets today, like say, in the Pacific Northwest. And this would have happened over, and over, and over again, all around the world. It was not one big flood, it was more like floods every year, all over the place, for 2 million years. And with all this rain, things were bound to change, and one of the biggest changes was the sudden abundance of dinosaurs. There are many misconceptions about dinosaurs. First of all, forget about the image of a huge predator towering over trees. A significant number of dinosaurs were not bigger than a good old turkey. Secondly, these dinosaurs that lived are very different from the ones that appeared at the end of this time span. Most of them started off small and grew more and more massive as the Mesozoic era went on. Interestingly, dinosaurs became more diverse and their population skyrocketed after a tragedy struck. There was another mass extinction that happened about 232 million years ago. Some experts link this event with the beginning of the volcanic activity and its consequences. But as soon as the climate became more humid, several million years later, there happened a boost of diversification. The era of dinosaurs started. Due to climate change, plant life on Earth changed dramatically. It thrived in the new tropical humid climate. Tall trees and lush greenery started to grow in abundance, and dinosaurs began to increase in size. Several theories explain this phenomenon. One of them states that thanks to the hot climate, dinosaurs didn't have to expend their energy on keeping their bodies warm. Instead, they could use it to grow bigger. Another theory goes that the reason for the appearance of huge dinos is the abundance of food, both for herbivores and carnivores. Let's compare several dinosaurs to prove the point. One of the first real dinos was Coelophysis. It was a creature that lived between 225 and 220 million years ago. This dino could reach almost 10 feet in length, but weighed just 60 pounds. No wonder it got the name holoform. This nimble bipedal predator fed on small amphibians and reptiles. Approximately 210 million years ago, there appeared an utterly new kind of dinosaur, a massive herbivore, Plateosaurus, aka flat lizard. This guy could grow up to 23 feet and weighed more than 3 tons. It was the first predecessor of enormous dinosaurs of the Jurassic period. The main peculiarity of this giant was its powerful tail and strong, separated teeth that helped the dino to munch on tough plants. After revitalizing the planet, the monsoon season finally came to an end. The volcanic eruptions were slowing down at that time, and this also played a significant role in the stabilization of climate. 230 million years ago, the eruptions finally finished. And while by that time, the world had already returned to its old, dry, and hot self, in some aspects, it had changed forever. After the 2 million year-long rainfall, the plant life of Earth changed dramatically. There appeared many types of conifers which then spread all over the place. And weird creatures of the Permian and early Triassic periods gave way to good old dinosaurs. Now, there's still the question of, what made it rain for 2 million years in the first place? Right before the rains came, some 235 million years ago, a huge burst of volcanic activity took place in Alaska and British Columbia. Today it's known as the Wrangellian eruptions. These eruptions lasted for more than 5 million years, churning out a layer of lava that got to be 6 kilometers thick and releasing enough CO2 to raise temperatures by about 3 to 10 degrees Celsius worldwide. And, over a very long time, warmer temperatures can create a wetter climate, because they can speed up the water cycle, driving more evaporation of surface water into the atmosphere, among other things. And in fact, because of this increase in atmospheric moisture, the CPE is also sometimes called the Carnian humid episode. Anyway, after about 1 million years of volcanic activity, the atmosphere became so warm and wet that rain could finally reach even Pangea's vast interior. Okay, but then, how did it stop? Well, when carbon levels are really high for a really long time, our planet can be pretty good at getting some of the extra carbon back into the ground where it belongs. Plants take it in and store it in their tissues, weathering and eroding rocks absorb it, and the oceans soak it up to form carbonate rocks like limestone. So as the Wrangellian eruption slowed down, the carbon cycle was eventually able to stabilize, excess CO2 was reabsorbed from the atmosphere, and the CPE gradually came to an end. By the time the eruptions had completely ended 230 million years ago, the world had returned to a classically hot, dry Triassic climate that only ended when Pangea began to break up. But even though the Carnian Pluvial episode was short, only 2 million years, its impacts on life were permanent. All that rainfall helped conifers spread and diversify, leading to the pine trees we know today. And while the start of the Triassic may have been the land of weird, crack-like things running on their hind legs, by the time the rains had ended, the world had fully entered the age of dinosaurs. What would you do if another 2 million a year-long period of rains was about to begin? Write about your survival ideas in the comment section below.